everybody, in this video we're going to talk about some of the other counting methods you can use for situations that don't involve permutations or combinations. So take 3 deep breaths and let's make this math easy. All right, so in our previous videos, we've talked about how permutations and combinations can help us count the number of ways that you can do things, or like the number of ways that you can choose a certain number of things from a certain number of options. So with permutations, we learned that the order does matter. So like, for example, having 15 people and choosing a president, vice president, and secretary. Versus with combinations, the order does not matter. So that would be like choosing a committee where it doesn't really matter who you choose first, second, and third. You just need to know how many ways you could choose a combination of 3 people. So there are some situations where you wouldn't use permutations or combinations because the choice tree looks different than a permutation or combination choice tree. Like, for example, let's say that you are trying to figure out how many 4-digit numbers there are. So we're talking about like actual 4-digit numbers, not like 4-digit PIN numbers. So what that would mean is like you can't have the number start with a 0, because if you had the number like 0, 5, 7, 8 or something, that wouldn't actually be a 4-digit number because that's the number 578. Which is a 3-digit number because we don't usually write zeros at the beginning of numbers. So if we thought about the choice tree that would create a 4-digit number, our first layer of choices would have 9 options because you can start the number with a 1, a 2, a 3, a 4, 5, 6, 7, 8, or a 9, but you couldn't start it with a 0. So the first layer of our choice tree would have 9 branches. But then for the second layer of our choice tree, we would have 10 options because you could repeat whatever number you had in the first spot, and you could also have a 0 because if you had a number, I don't know, like 1072 or something like that, it's okay to have a 0 in the second digit because overall it's still a 4-digit number. So I would have 10 options for what my second number could be, or my second digit, and then I would have 10 options for my third digit and 10 options for my fourth digit. And so my choice tree would look like 9 options for the first one, then each of those would branch off into 10 branches, each of those would branch off into 10, and then each of those would branch off into 10. And that would create a 4-digit number. And so the number of 4-digit numbers that there are would be 9,000, because 9 times 10 times 10 times 10 tells me that there's 9,000 branches in my choice tree. And as you can see, this isn't really a permutation or a combination because when you calculate permutations and combinations, you like decrease the number by 1, like kind of like a factorial type of a thing. And in this case, we're just keeping these numbers the same. So this isn't really a permutation or a combination. It's a different type of counting. Another situation where you wouldn't use a combination or a permutation might be if you were trying to figure out how many codes were possible that met these criteria. So the first character in the code needs to be an uppercase letter, the second and third characters need to be numbers, and the fourth and fifth characters can either be lowercase letters or numbers. So if I wanted to figure this one out, I would think about what my choice tree would look like. So I would say, okay, well, for my first character in the code, it has to be an uppercase letter. So I would have 26 branches in my choice tree for the first character. Then I would say, okay, my second character has to be a number, and there's 10 possible numbers because you have 1 through 9 as well as the number 0. And so I would have 10 options branching off of each of my 26 first options. And then for my third character, I would have each of those branches branching off into 10 options, because there was nothing in the restrictions that said that I couldn't repeat the same number twice. So I would have 10 options for the number in the third character spot. And then for the fourth character, it can either be a lowercase letter or a number. So there are 26 lowercase letters and 10 numbers, which means that there's 36 possible options for the fourth character. And then there's also 36 possible options for the fifth character. And when you multiply all of those together, that would tell you how many codes are possible. And when I multiply those all together, I get the result 3,369,600 possible codes. And so that's how you would calculate out that situation. And again, notice this isn't really a permutation or a combination, because the criteria that they gave me didn't restrict me from doing repeated numbers and letters, and I also had different options for the different characters. And so that's how you would calculate that. You might also have some situations where you'll be using combinations, but you'll be using multiple combinations. So let's say, for example, that you had 4 freshmen, 8 sophomores, 9 juniors, and 13 seniors apply for the student body leadership team. And you want to figure out how many ways you could form a team of 8. So the leadership team has 8 people in it, so that you have exactly 2 students from each grade level. Well, the way that you would calculate this is you would say, well, if I have 4 freshmen and I want to have exactly 2 students from the freshman class, then I would say, well, I have 4 options to choose my first freshman from, and I have 3 options to choose my second freshman, because you wouldn't choose the same person twice. And it doesn't matter which order you choose it in, because it's not like you're going to have a freshman president and then a freshman vice president. They're just all on the same team. So I would divide by the number of duplicates, which would be 2 times 1, because that's the number of ways you could arrange 2 people. And that tells me that there are 6 possible ways that I could choose my 2 freshmen. So that would be the number of ways I can choose my 2 freshmen, but I also have to choose 2 sophomores. So I'd say the number of ways to choose my sophomores, well, I would have 8 choices for my first one, 7 choices for the second sophomore, and it doesn't matter which order you choose them in, so I'll divide by the duplicates, and I get 56 divided by 2, which is 28 possible ways that I could choose my 2 sophomores. Then I would say the number of ways I can choose my juniors would be 9 times 8 divided by 2 times 1, because there's 9 juniors to choose my first junior from, then 8 juniors, but it doesn't matter which order, so I divide by the duplicates. And that gives me 72 divided by 2, which is 36. So there's 36 ways to choose my juniors. And then for my seniors, I would have 13 times 12, because there's 13 options for the first senior, 12 for the second, but it doesn't matter which order you choose them in. So you do 13 times 12 divided by 2, which tells you there's 78 ways to choose 2 seniors. And so you'd say, okay, well, that's the number of ways that you can choose each pair from each grade level. But the question asks, how many ways can you form an entire team of 8? So the way you kind of think about this is you say, okay, well, let's first choose my freshmen. So there's 6 different ways that you can choose your freshmen. So you would list out those 6 different possible combinations of 2 freshmen. Then after you've chosen which pair of freshmen you're going to choose, then you would choose your pair of sophomores. And there would be 8 pairs of sophomores that branch off of each of the 6 pairs of freshmen. And then you would have 36 pairs of juniors branching off each of those, and 78 pairs of seniors branching off of each of those. So the way that you would calculate the number of ways you can form a team of 8 is you would take the number of ways you can choose your freshmen, multiply by the number of ways you can choose your sophomores, multiply by the number of ways you can choose your juniors and your seniors, and if you multiply all of those numbers together, you get that there are 471,744 ways that you can form a team of 8 that has exactly 2 students from each year. And so basically the way that you use the combinations depends on what you're asked for. So like, for example, if you had been asked to just form a team of 8, but you had no restrictions of how many freshmen or sophomores or juniors or seniors you could have, then you would basically just say, well, I have 34 total people to choose from. You would choose 8 of them and divide by the number of duplicates to figure out how many ways you could form a team of 8. But if you had the restriction that they all had to be seniors, then you would say, well, I have 13 seniors to choose from. I would choose 8 of them, divide by the number of duplicates, because it doesn't matter who gets chosen first, second, and third, etc. But if you have the situation that we just solved on the last slide, where you have the restriction that you have to have exactly 2 students from each year, then you would do a combination for each of the grade years, and then you would multiply all of those results together. So you would choose your freshmen, and then you'd choose your sophomores, choose your juniors, choose your seniors, and then you would multiply all of those results together, because you're going to have a choice tree where you have 6 different ways you can choose your freshmen, then you have a whole bunch of ways you can choose your sophomores and juniors and seniors. So that's kind of the idea of using multiple combinations to find specific ways that you could choose a team or a committee or something like that. The last type of counting method I'd like to talk about is kind of related to the one we just did, but it's also slightly different. Because on the last one we did, we were counting the number of ways you could choose exactly 2 team members from each grade level. And in this case, we're choosing at least 1 female. So in this situation, we are choosing a 6-person committee from 20 males and 18 females. And we're looking at how many possible committees there are that have at least 1 female. So one way you could solve this problem is similar to what we just did. So you could say, okay, well, how many different ways could I have at least 1 female? Well, I could have 1 female and 5 males. That would meet the requirement. Or I could have 2 females and 4 males. Or I could have 3 females and 3 males. Or I could have 4 females and 2 males, or 5 females and 1 male, or I could have all females and 0 males. Any one of those would meet this requirement of having 1 female. And so I could go through and I could say, okay, well, if I choose 1 female, I would have 18 options, only 1 duplicate, and then I would take that result and I would multiply by the ways I could choose 5 males. So I'd do 20 times 19 times 18 times 17 times 16, all divided by 5 times 4 times 3 times 2 times 1, because that would be the number of duplicates. And you could figure out that number of ways. Then you do similar types of calculations for each of these other options. And then you would add all of those together, because those would be all of the ways that you could have at least 1 female. But this is very clunky and very difficult to do if you have tons of people. Because like, let's say instead of choosing a 6-person committee, you were choosing like a 20-person committee. Well, you don't want to have to go through and do like 20 calculations in order to figure out how many different possible ways you could have at least 1 female on a 20-person committee, because that would be a ton of work. And so it actually turns out that there's a shorter way to do this. And the way you think about it is by thinking about the opposite. So the opposite of having at least 1 female would be having all males. So the way that I would not have 1 female would be if I had all males. So the way I'm going to calculate this is I'm going to say, okay, I'm going to look at how many possible committees there are, period. And so the number of possible 6-person committees would be the number of people that I have total, which is 38. So I have 20 males, 18 females, which is 38 people possible. So I'll have 38 options for my first person on the committee. Then for my second person, I'll have 37 options, then 36, 35, 34, and 33 options for the people that I'm choosing on this committee. But it doesn't matter which order I choose them in, so I'll divide by the number of duplicates, which is 6 times 5 times 4 times 3 times 2 times 1. And that gives me the number of possible committees that are just chosen randomly, and it includes all of the possible committees. Then I'm going to say, okay, well, how many all-male committees are there? Well, if I can only choose males, that would be 20 options for my first person, then 19 options for my second, 18, 17, 16, and 15. And again, the order doesn't matter because it would still be the same committee regardless of which order you chose them in. So I'll divide by the number of duplicates. And that would be the number of all male committees. So the number of possible committees that have at least one female are basically all of these committees that are not these committees. So if I calculate out each of these numbers, the number of committees that I have total is 2,760,681, and the number of all male committees is 720. So the number of committees that have at least one female, the way that I would calculate that out is I would say, okay, well, if I have 2,760,000, etc., total committees, I would take that number of committees and I would subtract the number of all male committees, because those are the committees that don't meet the requirement of having at least one female. And what that tells me is that the number of committees that have at least one female is 2,759,961. And that would be the number of possible committees that have at least one female. So these are some of the other counting methods that you can use when you're calculating situations that don't really fit a permutation or a combination. So if you have any questions, let me know, and I hope that you guys have a great day.